Welcome dear students. So today we'll continue with what we are doing in the chapter number 12, midpoint and its converse, including intercept theorem. So that's the name of the chapter. So we are doing exercise 12a. Okay, so in the last class we saw till question number 6. Today we'll take question number 7. L and M are the midpoints of the sides AB and DC respectively of a parallelogram ABCD. Okay, so let's see what's the meaning of this. So see, there's a parallelogram given to you ABCD. Okay, it is said that L and M are the midpoints of AB and DC. So where is AB? AB is this one. So L is the midpoint of AB. So AB is there, so L is the midpoint of AB and M is the midpoint of DC. So this is the side DC, so M is the midpoint of side DC. Okay, prove that the segments DL, okay, so you see join D and L, so you get this segment, that is DL, and BM, okay, so BM is this line, trisect the diagonal AC. So see, this is the diagonal, isn't it? So question is saying that we need to prove that this line and this line is trisecting this particular line. So trisecting means this one and this length, they are equal. Okay, so let's see whether AX, okay, so basically we'll take the point of intersection of AC and CD, DL to be X, and the point of intersection of AC and BM is Y. So this is your X and this is your Y. Okay, so from figure you see carefully, very carefully. Okay, so BL is equals to DM. Okay, so see here carefully, I told you BL, okay, so BL is this one, is equals to DM. You know why? Because see here very carefully, now DC, since this is a parallelogram, AB and DC, they will be equal, right? Okay, and on top of that, since M and L are the midpoints, see DM will be equals to CM. Similarly, AL will be equals to this one, isn't it? So that's why this will be equals to, that is DM will be equals to BL. Okay, so from the figure this is clear. And also, you know, since this is a parallelogram, AB is parallel to DC, so that's why BL will be parallel to DM, isn't it? And that's why we say that BLDM, this is again a parallelogram. Okay, so therefore see this they are parallel for sure. Okay, they are equal also, isn't it? And see, this and this definitely becomes parallel here, isn't it? So that's why I am saying that BM, okay, so that is this line is parallel to DL because this is a parallelogram. Okay, similar, now see here from triangle ABY, so let's see where is ABY. ABY, so basically we are talking about this particular triangle. Okay, now see here carefully, I'm going to apply the theorem, that is what we have learned in the first class. Okay, so here L is the midpoint. See here, only in this triangle, if you see, L is the midpoint of AB, isn't it? And see, XL is parallel to this, isn't it? Yes, so in such case, can we say that X is the midpoint using the converse of the midpoint theorem? Yes, see here carefully, L is the midpoint, XL and these two are parallel, so that's why if these two are parallel, then this must be the midpoint of the side AY. Okay, alright, so from here what did you observe? If X is the midpoint, then AX must be equals to XY, isn't it? So that's what is written here. Okay, now we'll observe triangle CDX. Okay, so we have CDX, so just observe this. Now you know M is the midpoint of this and MY is parallel to DX, isn't it? Yes, so if these two are parallel, and if this is the midpoint, then obviously this y has to the midpoint of this particular side. Okay, so that's why we say cy is equals to xy in the same manner. Okay, so let me call this as equation 1, let me call this as equation 2. See here carefully, there is xy here, there is xy here, isn't it? So that means, can I combine these three together and write this one? Because x is equals to xy and this xy is equal to cy. So that's why in combined way I have written this one. That means ax is equals to xy and this is equals to cy. So what is the meaning of that? It means that the segments DL and BM trisect the diagonal AC. So hence, or else we can write this AC as ax plus xy plus cy. Okay, so hence we have proved whatever is asked. So you may pause the video and note down your solution. Let's have another question, question number 8, which says ABCD is a quadrilateral. So see here carefully, ABCD is a quadrilateral in which AD is equals to BC. So AD is equals to BC, that's what is given to us. E, F, G, H are the midpoints of AB. So basically E is the midpoint of AB. So let's see, where is E? Okay, so E is the midpoint of AB, F is the midpoint of BD. Okay, so where is F? F is here. Okay, so F is the midpoint of BD. So this is line BD and F is the midpoint. Okay, G is the midpoint of CD. Okay, so CD is here and G is the midpoint of CD. And at last we have H, and H is the midpoint of AC. So we have AC here, the midpoint of AC is H. Okay, now let's see what we need to prove. So here we need to prove that EFGH is a rhombus. So EFGH is a rhombus. Okay, so what is rhombus first and foremost? Rhombus is also a parallelogram where all the sides will be equal. Okay, in case of parallelogram, it's not necessary that all the sides has to be equal. If they are equal, then that particular parallelogram is known as rhombus. Okay, so basically here what you need to show is EF is equals to FG is equals to GH and is equals to HE. Okay, so let's see how to prove. Now, given that AD is equals to BC, right? So let me call this as equation number 1. Now from the figure, if you observe for triangle ADC and triangle ABD, first let's observe ADC. So ADC. So if you observe these, okay, you know, in this AC is there, right? In this triangle AC is there whose midpoint is H, and there's a side CD whose midpoint is GH. So what do you observe from here? Can I say that GH is parallel to AD? Can I say that? Yes. Okay, so GH is parallel to AD, and using midpoint theorem, this AD is going to be double of GH. Okay, so AD is equals to 2 times GH. And similarly, if you observe triangle ABD, so let's say where's ABD? ABD is this triangle. Okay, so I'm talking about this triangle. In this side, F is the midpoint, and in this side E is the midpoint. So that's why this line EF is just the half of this, or in other words, AD is double of EF, isn't it? Okay, so AD is double of EF. That's what is written. Okay, now this is also AD, this is also AD. So that's why if I combine these two, can I write 2 times GH is equals to AD, which is equals to 2 times EF. That's what is written, and let me call this to be equation number 2. Okay, same thing I'm going to do with triangle BCD. So let's say BCD. BCD is this triangle where G is the midpoint of CD and F is the midpoint of BD. So similarly, I can say that BC is double of GF using midpoint theorem. Okay, now let's observe ABC. Triangle ABC is this one. Okay, so in this triangle we have H is the midpoint of AC and E is the midpoint of AB. That means BC is double of HE, isn't it? So that's what is written. So here also we have BC, here also we have BC. Combining these two gives you this one. Let me call this to be equation number 3. Okay. Now you know AD is equals to BC. This is my AD. This is my BC, isn't it? So that means if these two are equal, then all of these has to be equal. Okay. So when you combine, we get 2 times GH equals to 2 times EF is equals to 2 times GF is equals to 2 times EH. So if you remove 2, what do you get? You get EF is equals to FG, right, is equals to GH is equals to AG, and that's what we wanted to show, because in a rhombus all the sides will be equal. So that's why we say EFGH is a rhombus. Okay, you may pause the video and note down the solution. Let's have one more question, and this is going to be the last question for the day. D, E and F are the midpoints of AB, BC and CA. So let me first quickly draw the diagram here. Okay, so from the diagram you see D is the midpoint of AB, isn't it? So D is the midpoint of AB, E is the midpoint of BC, E is the midpoint of BC, and F is the midpoint of CA. F is the midpoint of CA of triangle ABC. In triangle ABC, okay, so the midpoints of AB, BC and AC or CA are given to be D, E and F. AE meets AF. So where is AE? So AE is this one. So AE meets DF at point O. You can see that. P and Q are the midpoints of OB and OC. Okay, see here carefully. So this is my OB, isn't it? Okay, so P is the midpoint of OB and Q is the midpoint of OC. That's what is given. So we need to prove that DPQF. So DPQF. So this particular diagram is a parallelogram. That's what we need to show. Okay, so let's observe. Now given is triangle ABC. So whatever is given, so everything is mentioned out here. So we need to prove that DPFQ is a parallelogram. Okay, now let's see. Now in triangle ABC, let's see where is triangle ABC. ABC is this one. Okay, now D is the midpoint of AB and F is the midpoint of AC. That's for sure. So that's why if I apply midpoint theorem, I can say that DF is parallel to BC and DF is going to be half of BC using midpoint theorem. Similarly in triangle OBC, so OBC is this triangle. Okay, now if you observe this triangle, P is the midpoint of OB and Q is the midpoint of OC. So that's why we can say that PQ is parallel to BC and PQ is half of BC. Alright, let me call this as equation 1, let me call this as equation 2. Now from 1 and 2, this is also half BC, this is also half BC. So can I say that DF is equals to PQ? Can I say that? Yes. Okay, so that's why we have see DF is parallel to BC. PQ is also parallel to BC. So that's why DF is going to parallel with PQ, and with that if you see this half BC and half BC, if you remove these you find that DF is equals to PQ. Okay, so this is equation number 3. Now let's do the same with triangle AOB. Okay, so triangle AOB is this particular triangle. Okay, triangle AOB. So see, D is the midpoint of AB. Okay, and P is the midpoint of OB, isn't it? That means this is going to be parallel to this one, isn't it? I hope this thing is clear. So this triangle is given. D is the midpoint of AB and P is the midpoint of OB. That means if I join this line has to be parallel to the third side. Okay, and this DP has to be half of AO, isn't it? Okay, so see here carefully, DP is parallel to AE. Okay, so just wait a minute. Okay, so we have similarly triangle AOC. In triangle AOC, so this is not AE, okay, this is AO. Alright, this AO, remember this is also AO. In place of AE you must write AO. Okay. Similarly, in triangle AOC, F is the midpoint of AC and Q is the midpoint of OC. So join them. So this will be parallel to this one, that is AO. Okay, this is not AE, this is AO, remember. And on top of that, this FQ will be, or FQ or QF will be half of AO. So this is AO, remember. Alright, so that's why half of AO, half of AO. So these two are same, means DP must be equals to QF, and DP is parallel to AE and FQ is also parallel to AE, means DP will be parallel to FQ. Okay, so combining 4 and 5 we get this one. Okay, now DP is parallel to FQ, they are also equal. DF is parallel to PQ and they are also equal from equation number 3. So that's why using equation 3 and 6 we say that this is a parallelogram. Okay, so with this we close for the day. Thank you very much.